Okay guys, this is the second video that I promised you. Before you watch this one, please watch the other one because it goes through some of the easier problems on this unit test. Okay, so let's take a look at this problem here. We have jumbo eggs in Australia on average are supposed to weigh 68 kilograms. So notice guys, our H naught's going to be, our mean weight is equal to 68 grams. Our alternative is what? Well, let's see what we're predicting here. Margot is in charge of quality control, and Margot's probably making over $100,000 a year easily doing this job, by the way. And Margot is involved in quality control for these eggs. And so she's going to take random samples and test to make sure they fall in the given perimeter of 68 grams. All right. And as you can see here, notice what she's worrying about when they're significantly different than 68. Different means we don't know if it's less than or greater than, right? So that's why our alternative, guys, is going to be mu is not equal to 68 grams. Okay, it's going to be what we call a double-sided test. Now, of course, the results come out to be 67 grams on average for a random sample of 100 eggs with a standard deviation of 1 gram. We want to calculate the test statistic. So long story short, guys, it's going to go like this. We take what we have in our data, 67. We're going to compare that to our null hypotheses, which is supposed to be 68. So we subtract those and we divide by the standard deviation. So our test statistic T is going to be 67 minus 68. That quantity divided by our standard deviation, we were told, is 1. But don't forget you divide by the square root of the sample size. So there's our answer. So if you calculate that correctly, guys, you'll get a T statistic of like 10. And that was the correct answer. So guys, you got to know how to find the test statistic. All right, let's move on to, here's the actual work here, by the way. Oh, I also wanted to show you, of course, don't forget to practice with your calculator. We're going to do the same thing with the calculator. So up here, as you can see, is me just doing, actually it comes out to be -10. But anyways, so that being said, let's move on to what you would do with the calculator. With the calculator, notice we have only one set of data. She randomly sampled 100 of these eggs, right? So we're going to do a t-test, okay, on this situation, a one-sample t-test. We only have one sample. So once we select t-test, we're going to select stats. We're going to put in our mu naught. We're assuming it's 68. We're going to put in the actual mean of those 100 eggs. Standard deviation was 1, sample size 100, right? Notice we're going to select not equal to, because we didn't know ahead of time whether those eggs are going to be too big or too small. Well, it's going to be greater than or less than, right? So it's a double-sided test. And of course, right here, you can't see it, but we're going to select calculate. And here's our results. Notice our test statistic did come out to be -10. Notice how small our p-value is, guys. That E -16 means basically we have 15 zeros in front of this 1. It's going to be 0.0000 all the way up to 1. 15 zeros in here, right? So that's basically 0. So we have a 0 chance, in other words, that those eggs average 68. As it turns out, the eggs, for some reason, are a little bit smaller than they're supposed to be. But long story short, we would reject the null and conclude that we have sufficient evidence that proves that our eggs are not 68 grams. All right. Let's do at least one more. I'm not sure if I have time for another one, but here we go. We have this fast food company, and they're claiming that their half-pound burgers are actually a half a pound before, of course, you cook them. Alvaro's in charge of quality control at this burger establishment, and Alvaro's probably making, again, $100,000 or more. Just want to keep reminding you that statistics is a good field to get into. Another good one would probably be like accounting or finance, okay? But I digress. Notice our H0, guys, is, we're going to assume it is 0.5. But notice again, Alvaro does not know whether the burgers are going to be made accidentally too large or too small. So it's another not equal to, because we don't know, again, if it's less than or greater than 0.5 pounds on average. Alvaro took a random sample of 30 burgers, calculated a mean to be 0.49, standard deviation 0.04 pounds. He does the test statistic. He comes up with negative 1.37. The p-value was already calculated. Notice, guys, that's basically 18% there. All right, so our p-value is way too large. We would fail to reject, in other words. And that's the answer you're going to choose down here. You're going to choose, notice, by default, alpha is 5%. But because 0.18 is greater than 0.5, we would fail to reject H0 and have to conclude we do not have enough evidence to prove that the burgers are actually not 0.5 pounds. There's about an 18% chance that they're actually still a ½ pound burger, in other words. So not strong enough evidence to prove otherwise. Okay, so you're going to pick choice D, right? There is not enough evidence that it's different than 0.5. We're going to fail to reject because 18% is a lot larger than 5%. All right. Let's do one more. Camilla is curious about the average length of female blue whales. She randomly samples only 4 of them, so that's a little concern, but let's just go with it. We know her random sample size 4. They average 78 meters long, guys. Remember, there's over 3 feet in a meter, so these whales are over 200 feet long. Their standard deviation is 10 meters. The distribution of lengths in the sample is roughly symmetric. In other words, if we looked at the data plot, it looked like the other problem that looked like this, right? Where it was pretty symmetric in balance, like so. Okay. No obvious outliers. Good. Based on this sample, we want to make a 95% confidence interval to find or at least try to figure out what the true mean length of a female blue whale is. Well, how do we do that, guys? Well, first of all, we need to go back to our table, right? And let's see here. So let's go all the way back. Do I have it in this video? I do not. Doggone it. I forgot to take a picture. Let me just look ahead here. Maybe I have it in here. No, I do not. Doggone it. Okay, so we need to find that T-star value, right? So this is where you grab your T-table and look it up, guys. Okay, guys, so what I did, if you can't tell here real quick, was I went ahead and took a picture of my good, dependable T-table. Now, remember that the orange column here, if you look at the very bottom, is at the 95%. So what we're going to do, let me enlarge this here. Remember, if our sample size is 4, we're going to subtract 1. Our degrees of freedom is 3. So we're going to look at 3. We're going to go across until it matches the 95% at the bottom. Our value is 3.182. So, long story short, we're going to take our point estimate, 78. We're going to plus or minus 3.182 times, we were told our standard deviation was 10. And if you do this math correctly, guys, you will find the correct one of these intervals. I believe actually it's B, from 62 to 93.91. But I also want to remind you, you got to practice with your calculator. So if we go to our calculator here, guys, we would press stat, we go over to tests. In this case, we're making a confidence interval for one sample thing, right? One set of 4 whales. So we're going to select T interval. Once we select T interval, we're going to select stats. We're going to put in our stats, 78, 10, 4. We want to be 95% confidence. We calculate. And as you can see, it is answer choice B. Now, the calculator gives us a more accurate result, guys, because remember, we're rounding off whenever we use that table. Okay? But, guys, hopefully you're understanding this video and you're going to watch and practice with your calculator. Now, I think I have one more here I can squeeze in real quick. This one's a quickie, guys. Carlos is designing a video game. He's concerned that one of the levels is too difficult. In other words, it's going to take too much time for the average player to play that one level and complete it. It should be 45 minutes. So notice H naught is going to be, it should be H naught mu is equal to 45. Our alternative, you see, is going to be mu is greater than 45 minutes. In other words, it's going to make the game too difficult and too long to play. And that's the answer you're going to pick. So I just want to remind guys, remember, the initial hypothesis is always equal to, usually, of some sort, right? We assume everything is the same, everything is equal. It's the alternative we're trying to indirectly prove. In our case, Carlos is suspecting greater than. So that will be our alternative hypothesis. Okay, so guys, I hope this video helped you out. I hope, pray that you study and watch my videos as well as Mr. Khan's videos whenever I assign them to you. All right, I'll see you in class.